This lesson is Chapter 9.1, Linear Inequalities in Two Variables. The solution to linear inequalities in two variables is represented by coordinates that will satisfy the inequality. Graphing solutions to inequalities. Step 1, you want to make sure the inequality is in y equals form. So the y variable is isolated and is positive. You're going to graph the inequality like a normal linear function using the y-intercept and the slope. So we're doing linear inequalities here. So we have from 10c y equals mx plus b. Graph the y-intercept and use the slope to plot a couple more points and then create our graph. So let's do that. Step 2. If the inequality includes equal to, so less than or equal to or greater than equal to, then we're going to draw a solid line to join our points. If the inequality does not include equal to, so it's just less than or greater than, then we're going to draw a dotted or dashed line to join our points. And then step 3 would be to test a point on each side of the line and then shade the side that makes the inequality true. First example, give two possible solutions to the following linear inequality: y is less than x plus 1. So we're going to graph y is less than x plus 1. So we're just graphing y equals x plus 1. Our y-intercept is 1. And then our slope would also be 1. Remember, if there is no number in front of the x, then it means 1. Or as we move up, it's going to move to the right because it's positive 1. So up 1, right 1, up 1, right 1, up 1, right 1. If we want to go down, we'd go to left. So down 1, left 1, down 1, left 1, down 1, left 1, etc. And then we can join our points to create our line. Now this inequality, so first I have just my dots, and then I have to decide before I draw my line, is it going to be a solid line or is it going to be a dashed line? So looking at the inequality, y is less than x plus 1. So that means because it's not less than equal to, it's just less than, we're going to use a dotted line. Okay? So I could leave it as is. I'm just going to make my dots a little more significant, so turn them into dashes. There we go. So that is our line graphed. Now what we need to do is we need to test a point on each side of our graph and see which point satisfies our inequality. So I'm going to pick a point that is above the dashed line. Let's say that I go with this point here. It could be any point that's above this line. So this is the point -2, 3. Let's test that point. Okay, -2, 3. To test the point, we're just subbing it into our inequality and seeing if it's true. Y, which is 3, is less than x, which is -2 plus 1. 3 is less than -2 plus 1 is -1. Is 3 less than -1? No. -1 is less than 3. 3 is not less than -1. So that point is false, gives us a false result, which means that we would not shade that side of the equation. So testing a point that's on the other side, maybe I test 2, -1. plug in our values. Y, which is -1, is less than x, which is 2 plus 1. -1 is less than 3. -1 is less than 3. That is a true statement. Because that's a true statement, this means we're going to shade the side that to -1 is on, which in this case is below our line. So we shade this side. That means that any point that's in the shaded region is a solution to our system. We want to give two solutions. So we choose any 2 points in the shaded region. For example, I could choose even the point 0, 0 is in the shaded region. And then I could use my 2, -1. Example, graph the inequality y is greater than or equal to 2x plus 1. Looking at our inequality sign, it has an equal. So we're going to graph it with a solid line. Then the 2x plus 1, 2 would be our slope, and 1 would be our y-intercept. Let's graph our line y, graph y equals 2x plus 1. Starting with our y-intercept of 1, I'm going to increase this. Our slope is 2, which is also 2 over 1. So rise is 2, run is 1. From my y-intercept, I go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. From my intercept, I can also go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. Then I can join my points together because this one has an equal, so we're doing a solid line. And there is our graph y equals 2x plus 1. Next, we want to test a point on either side. So pick any point that's on either side of the equation and test the point. So I'm going to do, let's do -3, 1. I'm going to test points, starting with -3, 1. I take my inequality, y is greater than equal to 2x plus 1, and I sub in the point, y is 1, is greater than or equal to 2 times -3 plus 1. 1 is greater than or equal to 2 times -3 is -6 plus 1. 1 is greater than or equal to -6 plus 1 is -5. Is that true? Is y greater than, or 1, greater than or equal to -5? Yes, that is a true statement. That tells me that I'm going to shade this side of the line. Now, I could stop there, but I just want to make sure that I didn't make a mistake. So I'm still going to test a point that is on the other side of the line just to make sure. It should come out with an incorrect inequality in the end, but I just want to double check. So let's try the point 42. Y is greater than or equal to 2x plus 1. Sub in our values. 2 is greater than or equal to 2 times 4 plus 1. 2 is greater than or equal to 2 times 4 is 8 plus 1. 2 is greater than or equal to 9. Is 2 greater than or equal to 9? No, that is false. So again, it tells us that we are shading the above part, or the part that's on the left. So shade the side that -3, 1 is on. In this case, above or left. If at all possible, we want to try to keep the y variable on the left-hand side so that it matches our graphing calculator. If when solving for y, you end up multiplying or dividing by a negative number, then you have to flip the inequality sign. Let's rearrange this one. We have 3x minus 2y is greater than -6. So I want to keep the y value on the left-hand side, and it's going to subtract 3x from both sides. And we get -2y is greater than -3x minus 6. Now I need to divide by -2. When I divide by a negative, that means I have to flip the sign. If I multiply by a negative, same thing. So dividing or multiplying by a negative, flip the inequality sign. So we get y is less than -3 divided by -2 is 3 over 2x, and then -6 divided by -2 is +3. Our linear graph that we're drawing, we don't have an equal sign with our inequality, so this is going to be dotted line. Our slope is 3 over 2, rise of 3, run of 2, and our y-intercept is 3. Y-intercept at 3, slope of 3 over 2, 1, 2, 3, right 2, 1, 2, 3, right 2. If we want to go down, down 3, left 2, down 3, left 2, down 3, left 2, down 3, left 2. This is a dotted line. There's our line. Next we need to test some points. Test 1 point on each side. Choosing, I'm going to start on the right side. I'm going to choose real easy, 0, 0. My inequality is y is less than 3 over 2, so 0 is less than 3 over 2 times x, which is 0, plus 3. Well, that's going to be 0, so 0 is less than 3. Is that a true statement? Yes, 0 is smaller than 3. So that is true, which would tell me that I would shade on the right side or below our line. But let's test the point that's on the other side just to make sure. So I'm going to test -4, 2. Sub it in, y, which is 2, is less than 3 over 2 times x, which is -4 plus 3. 2 is less than, can use our handy dandy calculator. We have 3 divide 2 times -4 plus 3. We get -3. So is 2 less than -3? No, it is not. So again, we see that we should shade this side. So the solutions to this inequality is any point that is on the shaded side. Shade on the side with 0, 0. Use a graph to show all possible combinations of amounts of tile and stone that can be used to make a mosaic. Tile costs $2.50 per square foot, and stone costs $6 per kilogram, and the budget for the mosaic is $150. Let's let T equal number of square feet of tile, and S equals number of kilograms of stone. We need to write an inequality. We know that our budget is $150. We can't go over budget. So our equation has to be less than or equal to $150. The total cost of the tile would be $2.50 times the number of square feet of tile, which is T. The number or the cost of stone would be $6 times the number of kilograms of stone, and that added together has to be less than or equal to $150. Let's isolate one of our variables. It doesn't matter which variable we isolate because they're not called X and Y, so just pick one of the variables to isolate. I'm going to isolate S. So I'm going to subtract 2.50t. I get 6s is less than or equal to negative 2.50t plus 150. I'm going to divide by 6, and then we get, let's see, negative 2.5 divided by 6. Change that to a fraction by doing math. Enter, enter. Negative 5 over 12t, 150 divided by 6 is 25. We know that the sign with an equals means we graph with a solid line. We can use, this slope is kind of hard to use to graph, but we can use our y-intercept to plot a point. And then we can also use our graphing calc to find the x-intercept to help us draw the graph. Let's do that. Y equals, we're going to enter our equation, bracket, negative 5 divided by 12, close bracket, x plus 25. Graph. And if your windows are, let's say Zoom 3, this might be what you see, which is a whole lot of nothing. You gotta think about the situation. We're not gonna have negative numbers of square feet of tile or kilograms of stone. So we really just want to focus on quadrant 1, the positive. So if I go zoom fit or zoom auto on a Casio or window, zoom auto, I think it is 6 in this case. So I want to that gives me a starting point. Then I go to my window. I don't need to see any negatives, so I can change that to a 0. for my y min, or my x min. My x max, I want to make bigger, so maybe I try 50. My y min, I want to see 0. And my y max, maybe I also try 50. Actually, I know my y-intercept is 25, so I just need to see it there. So maybe I just try 30. And then I graph. Okay, I still can't see my x-intercept. I want to go higher on the x max. I want to go see more to the right. So window, x max. 50 wasn't enough. Let's try 80. And then graph. Good, now I can see it. I want to find the x-intercept, second, trace, number 2 for 0. I need to be left bound, so I put my little dot on the left side, which in this case is above the x-intercept. I hit enter, then I need to go to the right, so I use my right arrow to move my little dot until it is definitely right of the x-intercept, which it is. I hit enter. Do I want to guess? No. Hit enter again, and it's 59.999, so 60. Okay, so my x-intercept is 60. Now we can graph. So we need a title. Let's say this is a budget for the mosaic. So let's say mosaic budget. We made our t value the x, and it goes from 0 to 60. So if I look, 1, 2, 3, 4, 5, 6, 7, 8, 9, I have 10 spots, so we're going to count by 6s. I'm going to skip and go to 12, 24, 36, 48, and 60. And that is amount of tile in feet squared. And then for the stone, our y-intercept is 25, so we need to go up at least to 25. We have 2, 4, 6, 8, 10 increments. So if every second one is 5, 5, 10, 15, 20, 25. And that is amount of stone in kilograms. Okay, our y-intercept is at 25. Maybe I'll do my graph in different color. Our x-intercept is at 60, and we can join those points with a line. Next step would be to pick a test point on each side of our line and check it with the inequality. So let's do that. I'm going to pick 24, 20 as my point above the line. Let's test that. I'm going to plug it into the original version of my inequality, but it doesn't actually matter which one you use. 2.50 times our number of tile was 24, plus 6 times our amount of stone was 20, so less than or equal to 150. Let's calculate the left side, getting out of the graph back to the calculator. 2.5 times 24 plus 6 times 20 is 180. 180 less than or equal to 150. Is that true? No, 180 is greater than 150. So that indicates that we're going to be shading below, but let's just double check and make sure that it's true. We'll use the point 12.5. Going to sub it in. 2.50 times 12 plus 6 times 5 less than or equal to 150. Calculate the left side. 2.5 times 12 plus 6 times 5 gives us 60. It's less than or equal to 150. That is true. 60 is smaller than 150, which tells us to shade below the line. So our solution region is all of this in here. Any point in that shaded region or on the line, because it's less than or equal to, would be a solution to this system. And that's the end of lesson 1 for chapter 9.